In this presentation, we're going to be taking a look at the black hole attack and how it looks from an atomic point of view and a holistic point of view. In this presentation, we're going to be using fluency. And what fluency allows us to do is to fuse the data from the network activity along with the alarms that are coming from devices like Snort or from VirusTotal. To review, an atomic response is something that we get when we get an alarm from an IDS or an IPS, and we can see where it's coming from and where it's going to. This is normally the case when we're using a dedicated alert management system, like a trouble ticketing system, or a SIM, in which we get alarms from a number of different places, but we only get to see the alarm. There's no holistic view of it. Now we're going to show you, using fluency, we can get this holistic view. We can see the activity that's occurring before and after the alert, and we can collect a lot more information about how to respond to the attack. So as we go through the interface and we take a look at this attack, we're going to go first look at how this information would look like in a SIM, and we're going to build up using scoping and pivoting all the other activity around the signatures. And when we're done with it, it's important to understand how holistic this response is against this attack. The key concept of pivoting and scoping, tagging, these are very easy things to train and understand, and as regular SOC personnel can very quickly understand how to use a tool that's a lot more interactive like fluency to be able to get the most out of the signatures and really the most out of the infrastructure that an organization pushes out. Let's take a look at a black hole exploit kit and see the difference between atomic and holistic. So to start, let's take a look at just the signatures that would have alerted. And this is an atomic response. An atomic response would have seen these yellow markers and the blue, not the red. The red is added by fluency by doing what we call artifact analysis, and we'll get to that. When we have an atomic response, what we have are these signatures triggering, telling me that this victim IP is being attacked by this server IP. And if we have high confidence signatures like these are, we can pretty much know that this system was attacked, and by seeing these executables downloaded, we know they're infected. So right now, what the defender has to do is defend against this IP address coming in, and we're going to see that there's actually two different IP addresses or three different IP addresses here associated with the attack. So we're going to block those three IP addresses, and then we're going to possibly block using these signatures, and then finally we're going to recover this system because we know it's infected. So those are really the 1, 2, 3 of an atomic response. Well, what else more could we have done? So let's look at it from a holistic point of view. So one of the first things we just said was that we have these artifacts, and we've run these artifacts through VirusTotal, and we know that we have these hits. Now, instead of right mouse clicking when we think we have a problem, we can actually just send all the MD5s to VirusTotal and ask VirusTotal its opinion. And so when we do that, we get a little bit of a different picture. We actually now get to see other machines being involved. We just see this machine from Romania, which has a host name that's all numbers. And this is an unsigned 32-bit int. It's a trick to get around DNS filtering. But we can see that the attack also includes jar files. And this is not unusual. The black hole, just like all the other exploit kits, use multiple exploits. And so we shouldn't just see one attack or even two attacks. We should see a number of attacks being launched against the victim. If we only see one or two, it means that we have gaps in our signature coverage, again, that need to be addressed when we talk about a persistent defense. Now, we've got this attack, so now we have a new IP address that we can add to our list. In Fluency, we would do that by clicking on the summary capability. And you can see this one's already been added, but we would have created a filter or create a tag to follow it. Now, this is a key aspect. There's three stages of things that we want to do. The first is we want to detect, and we can use some of our validation engines like we just did, the VirusTotal piece, to actually discover new things. So even though they're validation components, we can use them for detection. The next step is validation itself. We want to validate that these are the good. So when we talk good, we mean good hits. And what we're saying here is that we're trying to find our true positives that we know we have issues with. In this case here, when we get a bunch of responses from VirusTotal, usually greater than 4 or 5, we know we have a significant issue. The other thing is we can rely on certain signatures, so we can tag those. So the second step is validation. Now, once we go through all these processes, we're going to have a number of different attributes that we can respond to. Those will be the victims, the attacking IPs, the attacking hosts, the files that are moving, even things like name servers. And we can mark all that information and we can respond in a holistic fashion. We can also search for the gaps, and that's one of the things that we're going to do right now. Is we're going to show you some of the gaps that we missed other than this jar file. Lastly, we're going to use these tags so that we can track any further activity. And when we find further activity, we're going to repivot and look for gaps again. And this is what a persistent defense is all about. So let's go back to the flow of the data, and we're going to open it up all the way. So we're going to take a look at all the data set, and we're going to follow this flow till after we see the exploit. And after we see the exploit, we can then see the calls occurring going out, and we can validate these calls. So in this case here, we see that there's a hit, there's a machine that's going to, and we can evaluate this machine and find out that this is, yes, one of the covert channels. The analyst, again, would click a summary to analyze that, and they would create a filter. And this time here, they create a filter saying this is a command and control. So they're going to go through this process of evaluating what happens after an executable. They can also notice that there's failures that occur. So here's a site that's going to Japan and it fails to connect because defensively somebody's already figured out it's a bad site and they've already blocked it. And that's another attribute of the exploit kits, is that after an infection, the virus tends to go hit sites that are inactive. And so we can actually use the failed port connections to help find some of these infections. Again, we can go down the list and find the machines that are calling back and doing so successfully. And the successes are those 200s. We can actually search for those type of activities by using a Lucene search in the very top. Now, when we're done with all this analysis, we kind of get a picture that's a little fragmented. And the reason why is because we're looking at each stage. We can see the exploit kit and all the activity, the fast flux information, all the activity, the KZ, which is the actual viruses being downloaded, its activity, and finally the command and control. And this draws a much more holistic picture other than just the signatures that we're alerting. So now we're going to go back to the presentation. We're going to see what is the difference when we add this all up. When we pivot the tree and we use that pivot to say, show me everything around the victim, how does the difference in the report look? Now, what happens when we pivot around the victim's IP address is that we find that from an atomic response, we would have said there were 3 IP addresses that we need to stop. From a holistic response, we see that there are 10. It doesn't mean there are 10 in the initial attack. We see that out of the initial attack, 7 are from there, 3 are from the covert channels, which means that if another attacker was to come in, or there was a BYOD attack using these same files, that we would have the covert channels to be able to say, we see that activity, and be able to track it. That key aspect, that third aspect, tracking, we could have been tracking it through these other IP addresses. The second part of this is that holistic gives us the name of the hosts. A lot of times when an IDS or an IPS alerts, it has the information from the connection from the source and the destination, but unless the initial triggers were during the exchange of the host name, they're not there. Fluency collects that information on top of it. So now we have all the names of the host to include the fastflux host. And we can tell from this host name that this is not a DGA. In other words, it's not changing. The IP addresses were changing. In fact, blocking those IP addresses from this particular host name isn't going to be helpful, but knowing the host names is very helpful. And so now we know how to both track and prevent this attack by using its host names. Also, we have all the files that were exchanged. We can do further analysis in Sandbox, plus we have the MD5s, which we can send out and find out if it exists in any of the desktop systems. Lastly, we do have the signature hits, but that's what Atomic would have given us anyways. The signatures gave us the key elements to begin the investigation. In further presentations, we'll go through it when we only have 1 or 2 hits, and we'll build holistic data from there. Now, with all this holistic information, it's important to understand, yes, we could prevent this attack, but more importantly, it's to understand that we can now track it. So as the attacker changes, let's say, a host name or an IP address, they might even change the exploit kit they're using. We have enough information around it now where we can track other elements. In fact, what we see with most of the cases is that as time goes on, the signatures become less and less relevant. And the tagging, however, becomes incredibly strong. And we can track the attacks, modify our defenses, and keep the attacker out by keeping constant awareness of when the event occurs and then pivoting around it to make sure we have a holistic understanding. Now you should have a clear understanding of what we mean by atomic and holistic responsing, and the importance it is for especially a security operations center to see things holistically. We've always talked about having network vision and the ability to see the attack. The capability of fusing metaflow data along with system log data is a tremendously powerful technique that you're going to see more and more organizations trying to do. And Fluency will give you that capability today.